Okay, this video will cover the first day of section 3.2 for the sophomores who were not here. And in this section, we learn 4 new reasons that we can use in proofs. One of them is a postulate, 3 of them are theorems. And if you recall, a postulate is something that we accept without proof. It cannot be formally proven, but it's an intuitive idea that we accept. And then the other 3 are theorems, which 2 of which we will prove today. So we're moving on with our study of various types of angles that are created when a transversal cuts through 2 lines. But today we will only be dealing with parallel lines. Okay, parallel lines are going to be indicated with a mark like this. Okay. And I'm going to cut through those parallel lines with a transversal to discuss our first postulate, which is that if 2 parallel lines are cut by a transversal, then corresponding angles are congruent. So in this diagram I've created up here, perhaps we can label these as 1 and 2. From our studies yesterday, or last class, we decided that angles that can both be said to be in a similar location, like in this case the upper right corner, when a transversal cuts through 2 lines, we call those angles corresponding. And it turns out that you can measure this with a protractor over and over and over again with transversals cutting at different angles, and you will always find that those 2 angles are congruent. We can't prove it formally, so it is a postulate, but it's going to be one of our new reasons that we can cite in proofs. And you don't have to write down all of this language when you use it. If you like, you can just write parallel lines, then an arrow. So if parallel lines, then corresponding angles are congruent. We're going to use that idea in our next reason, which is going to be a theorem. And this theorem is going to be if 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. Alternate interior angles are congruent. Well, let's draw a new diagram. So I'll create some parallel lines. I'll mark them as such, put a transversal through. Okay. And I'm going to include a pair of alternate interior angles, so 1 and 2. And I do need one more angle to prove this, so I'm going to include angle 3 here. So my proof, unsurprisingly, starts with the given information. Let's call this line K and this line N. And what I need is a way to start talking about angle 1 and angle 2. Now, I don't know anything about their relationship yet, but I do know something about angle 1 and angle 3. If you look at angle 1 and angle 3, you can see that they're actually corresponding angles. And we just learned something about corresponding angles in the postulate above. We learned that if lines are parallel, then corresponding angles are congruent. Now that's great. I've got 1 and 3 in the works here, but what I'm supposed to prove includes angle 2. So I need to get angle 2 in the works here. And the only thing that I can say with authority about angle 2, given what I know so far, is that angle 2 is congruent to angle 3. Now if you look at the diagram, you'll recall that vertical angles, like angle 2 and angle 3, are congruent. And then finally, I've got angle 1 set equal to angle 3, or congruent, excuse me. I've got angle 2 congruent to angle 3. Let's cut out the middle here. Let's cut out the idea that angle 3 needs to be in the mix. And I can say now that angle 1 is congruent to angle 3 by substitution, or transitive property. Okay. Now that I've proved it, we can use it. So our new reason, okay, we've got parallel lines. If parallel lines, then alternate interior angles are congruent. 2 down, 2 to go. All right, next, if two parallel lines are cut by a transversal, then same side interior angles are supplementary. Supplementary, so not congruent. All right, let's get a diagram going here. Erase this so I've got a little more space to squeeze in a diagram. Just green and create two parallel lines with a transversal going through them. And this time I am going to make 1 and 2 same side interior angles, and then I'm going to include one more angle that'll help us prove this, angle 3. All right, so unsurprisingly our given is K is parallel to N. And as I prepare to write my second statement, I look back at what I'm supposed to prove. I'm supposed to prove that two angles are supplementary. The word supplementary means that angles add to 180 degrees. So it would be really good if I could get 180 degrees in one of my equations. And looking at the three angles that I've mentioned, hopefully you see that 3, whoops, trying to highlight here, 3 and 2 make a straight angle, therefore add to 180. So I can say that the measure of angle 3 plus the measure of angle 2 equals 180. And in that case, that's angle addition postulate. I know it's tempting to say definition of supplementary angles, but we were not told that 3 and 2 were supplementary. We were told 1 and 2 are supplementary. So you can't cite the definition of supplementary angles if that word was not used in relation to the two angles in the statement. All right, great. I've got 3 and 2 are supplementary, but I really need 1 and 2. I need to somehow get 2 in the mix here. Now, if you look at angle 1, okay, I do know its relationship to angle 3 from the last proof. We just learned something about angle 1 and angle 3. They are alternate interior angles, and we learned that alternate interior angles are congruent. So I can say that the measure of angle 1 is equal to the measure of angle 3 by my new reason, which is lines parallel. If the lines are parallel, then alternate interior angles are congruent. And then finally, well, not quite finally, I've got 2 steps left to go. I'd really like to get rid of angle 3 in this statement, statement 2. There is no angle 3 that's going to be spoken about in the prove line, so what I need to do is replace angle 1, or excuse me, angle 1 with angle 3 with angle 1, excuse me. So I'm going to rewrite the statement in 2, but instead of angle 3, I'm going to have measure of angle 1. And that's a substitution. And then finally, I do have to write this sentence down. Angle 1 and angle 2 are supplementary. And the reason they are supplementary is because they add to 180. That's the meaning of the word. Therefore, the reason is definition of supplementary angles. Okay. All right, the final theorem I'm not going to prove. It's not one that comes up very often. Okay. Basically, it says if you have two parallel lines and you know one of the angles is 90, not only do you know that all of these are 90, but you also know that the next intersection has all 90-degree angles. This is a little bit redundant with the corresponding angles because of course these two correspond and of course they are congruent, but sometimes it's nice to have a special case theorem for perpendicular intersections. At this point, what I'd like you to do is work on these practice problems, okay, utilizing your new relationships. Your new relationships being the following. We know alternate interior angles are congruent. We first learned about corresponding angles. Oh, sorry about that. Let's close that for a second. Corresponding angles are congruent. And then finally, we also learned that same side interior angles are not congruent but supplementary. That's going to feed into all of these questions down here. Okay. While you're working on these questions, please be aware of the following. When you see quadratics, you do need to factor or use the quadratic formula to solve them, and you need to check your answers really, really closely, because quadratics can provide answers that when you plug them back into the original values here, you might get negative angles, and we know that negative angles are not going to be practical answers. So please be sure to check both your answers when you have a quadratic to see if they are reasonable. Okay. Please go through the second page, and one thing that I forgot to do is mark these parallel. So please take a moment before you work on this sheet. Mark all of the lines that appear to be parallel as parallel. Usually I do this before I put it into the copier. Okay. These are parallel and these are parallel. We've got a double set here and here. Okay. And then I've pretty much already made this list at the top of the second page, so you can fill that in. We learned about 3 different kinds of angles. We learned about corresponding. We learned about alternate interior, and we learned about same side interior. So just fill those ideas in. And then please do this problem, and this proof. Okay. You do not need to address the 4th page. We're not quite there yet. Also in the Argenda library is a filled-in version of all of these problems with the answers, so you can check your work, and then please come into office hours with any questions and I can go over it with you. I hope you had a great day on your retreat or service day, and I look forward to answering your questions when you come back.